Now I'll start with the last topic of our first unit, and that is we are going to have introduction to hybrid and electric vehicles, and we are simply going through the various architectures which are used in the electric and hybrid vehicles. Okay. So you are not able to answer or unmute yourself as you attendee.
No, ma'am. We can answer.
You can. Okay, then we are starting with this electric vehicle and hybrid vehicles. Okay. So basically, electric and hybrid vehicles is the change that is made in the drive system, and we are going to just study what are the changes in the drive system of this hybrid and electric vehicle. Okay. So as the name represents hybrid vehicle and electric vehicle. So if we are talking about electric vehicle, it will be operated on, it is fully operated on the batteries. Okay. And as the word hybrid is representing, it is operating on, it is using more than one input sources to drive your wheels or the vehicle. Okay, so it is using your IC engines, the existing IC engines, as well as it is using the batteries as the supporting system. Okay, and that is why these are known as the hybrid vehicles. Okay, so hybrid cars are the vehicle whose accelerative force is provided by more than one source. As we said, one of the sources your IC engine, and another source that is we are using is the battery. Okay, so these drive sources obtain the energy that is required from variety of sources. The term that is currently used to describe these vehicles is HEV, that is hybrid electric vehicle, and it is a combination of internal combustion engine, that is IC engine, with one or two electric motors and associated energy accumulators. Okay, so this is a hybrid vehicle. So why hybrid vehicles? What is the advantage of hybrid vehicles over the conventional vehicles? Okay, so the hybrid vehicle provides good performance and long operating range by utilizing the high energy density advantage of petroleum fuels. Okay, so basically, if we compare only battery operated vehicles and only the fuel operated vehicles, the advantage of fuel operated vehicles is that it is good for long distance drive. Okay, so it is giving us good efficiency or good operating range. Okay, so it is better for long operating range, whereas your electric vehicles currently are not, we cannot use it for longer distances. We need to frequently we need to charge those vehicles. Okay, so that is the main advantage of your hybrid vehicles. Okay, so which utilizes the or which uses the advantages of your IC engine as well as battery operated engines, battery operated vehicles. Okay, where conventional IC engine vehicles have the disadvantage of poor fuel economy, okay, and environmental pollution. Okay, so this can be improved by just adding the additional driving power through the batteries. Okay, so the main reason of their poor fuel economy are mismatch of the engine fuel efficiency. Okay, with real operational requirement, dissipation of vehicle kinetic energy during braking. Most of the energy we are wasting during the braking, and that is making utilized in case of hybrid or electric vehicles. Okay, low efficiency of hydraulic transmission in current automobiles in stop and go driving patterns. Okay, so whenever your vehicle is in the halt mode, whenever it is stopped, still your engine is working. So it is consuming the vehicle power, engine power. Okay, So that can be again utilized in case of your hybrid engines. Okay. So battery powered electric vehicles on the other hand possesses, so we have discussed the limitations of our fuel IC engines, conventional IC engines. Now what are the battery powered electric vehicles? The advantages of those vehicles, those possesses some advantages over conventional, such that it has high energy efficiency and zero environmental pollution. Okay. However, the performance, especially the operation range per battery charge, is dependent on the battery charge and is far less compared to your IC engines, as I already discussed. Okay, so the charging, it totally depends on the charging capacity. The performance totally depends on the charging capacity of the batteries, that battery packs that we are using in our vehicle, and which is currently, it is very less as compared to the IC engine vehicles. Okay, and due to much lower energy density of the batteries as compared to the gasoline. Okay, so this is the main drawback, and hence the combination will perform better than individual. Recently, lot of studies going on to increase the battery performance. Okay, the energy density that can be obtained, the energy that can be obtained, or the power that can be obtained from the battery. The research is going on how it can be increased, how it can be made so that it will work for the longer duration and all those things. Okay. So hybrid electric vehicles which use two power sources, primary and secondary, have the advantage of both these IC engines and electric vehicles, and hence it's better to go for hybrid instead of conventional electric energy. These are few statistics actually taken. These are the old PPTs actually. So it is representing the statistic, the oil consumption in terms of barrel, okay, per day. So you can just see worldwide, if we saw that figure, it is in 2007. That means you can just imagine that like what factor it might have increased currently. Okay, and another factor is the reduction in the oil reserves. Okay, and hence at a particular time instance, or at some point of time, so it may happen that there is the deficiency of this fuel may exist, and because of what the research has been shifted to electric vehicles or the battery operated vehicles. So this, we know the effect of fuel. Okay, we have discussed this initially. And hence, what is the conclusion is that in case of hybrid cars, we can get better fuel efficiency, theoretically up to 80%, less emissions, and lower maintenance is required as compared to your conventional IC engines. Now, basically, you need to think of where exactly your fuel energy is going to consumed, okay, and how much is the output energy. Actually, what percent of your input fuel energy is reaching to the drive, this wheel drives, drive wheels. Okay, so here it has been represented. This, if we are considered the input as the 100% fuel energy, so out of which 17.2 is we are losing it whenever your vehicle is in the idle mode, okay, in the standby mode. So 62% are the engine losses we are getting for operating your engine, okay, combustion and all that engine process. Okay, 2.2% is the auxiliary systems, those are driving, that we are driving. Okay, and 5.6% we are losing in the drive line losses. Okay, and finally what is all that we are getting is only 12.6% is reaching to your drive wheels. Okay, and we can just increase this fuel energy by number of ways. Okay, so by utilizing your braking power and using the batteries instead of engine power, the battery power can be used to drive your auxiliaries and all those things. Okay, so we'll see now the advantage of or how your hybrid vehicles are advantages, or how these losses can be avoided. So it can be avoided because of working of your hybrid vehicles in these three different modes. Okay, so one we are talking about, it is known as the regenerative braking. Another is we are taking assistance from the electric motor to drive the vehicle, and second is automatic start and stop. Okay, so we'll discuss one by one what these three modes are. Okay, so regenerative braking recaptures energy normally lost during the costing. Costing is nothing but cruising. So cruising, we are not fully utilizing the engine power. Okay, so whatever is the excess power that is required, so that can be utilized by just forwarding those. It uses the forward motion of the wheels to turn the motor. Okay, so just whatever is the remaining energy that can be used to drive your motor, which works like a generator, and that is used to charge your batteries of the vehicle. Okay, so in cruising your vehicle, there is no need to change the speed. Your vehicle is operating on a constant speed, so the energy or the power that we are consuming from the engine is not fully utilized. So whatever is remaining, that remaining energy or unrequired energy or power will be transmitted to the to drive the motors, which works like a generator. Okay, and hence that generating power is used to again charge your battery vehicles. That is known as regenerative braking. Okay, or sometimes we can not only in the cruising, whenever you are braking your vehicle, in that case also most of the energy engine power will be lost. So instead of just wasting those power, that can be utilized to charge the battery vehicles. Okay, vehicle batteries, electric motor drive and assist. Okay, so in this particular mode we are using, so sometimes whenever your vehicle is you are driving your vehicles on the climbs, you are climbing the hills. Okay, so at the hilly areas for hill climbing, or whenever you want higher speed. Okay, so in that case the motor power is insufficient to drive your vehicle. So in that case, additional power can be obtained from the electric motor. So power from engine as well as motor will be combined to drive the vehicle. So in that case, load on the engine will be reduced and your vehicle can drive smoothly without any loss of the fuel, or more consumption of fuel, and with minimum power requirement. Okay, so that is your electric drive or assist mode. Automatic start and stop, I think nowadays it's very common in most of the vehicles. So whenever you are waiting at the signal, okay, so automatically your vehicle will be stopped, so that engine will not work, and whenever your engine will be stopped, so for that particular time duration your auxiliary systems are driven by the batteries. Okay, so and after particular time duration, automatically your vehicle will start. So obviously whenever engine gets stopped, the fuel consumption will be stopped. Okay, so engine working will be stopped, means we are getting power as well as fuel efficiency, as well as the working efficiency of the vehicles, pollution, everything can be controlled, or it will be improved if your engine is not working. So like this, in hybrid vehicles, we can improve the efficiency of the vehicle, the working efficiency of the vehicle by these three different factors. Okay, so how these things can be obtained in case of your hybrid vehicles, or what are the uh, different architectures of hybrid vehicle drivetrains? So that we'll see. Basically, initially there were it will be series and hybrid only, but again nowadays we can find the combination of series parallel as well as complex hybrid. Okay. So this represents your series hybrid architecture. So I have taken this from two different books, and it is simply represented. You can observe both are same. Okay. So here it is representing your IC engine assembly, which is connected to the motor, which is acting as a generator, and that generator is coupled to the electric motor through power converter circuits, which is known as electric or electronic coupler, and to that particular, so this is actually combining the power from IC engine as well as battery, from the batteries. Okay, and that combined power will be given to the electric motor, which is used to drive your transmission. Okay, so this is, as it is the complete assembly of this electric motor is connected in series with the IC engine, so it is known as the series. Actually, it's not series hybrid. Okay, so this is series hybrid drive line architecture. Okay, so the same thing is represented. So this 1 and 2 are representing your IC engine, fuel tank, IC engine. So this is representing the alternator, which is nothing but the generator. Okay, and batteries, these are connected, these two things are connected here. Okay, and through this electric motor, the electric motor is used to drive your wheels. Okay, so this is your series hybrid. Now how exactly the same block diagram has been just represented in more detail in this diagram. Okay, so basically it operates in the 7 different modes. Okay, so what are those modes? We'll see. Okay, so sometimes your drive is required, the engine power is sufficient to drive the wheels. Okay, so this is represented your traction mode and battery charge mode. Battery charge is nothing but whenever your vehicle is in idle or in the stop condition, so, or the braking power. So all those things at that time we are using the engine power as well as the motor power to charge your batteries, to just charge the battery packs. Okay, so that is represented, the path is represented by dotted lines. Okay, whereas this is representing your traction or the speed flow or the speed transfer from the engine to the drive. Okay, or torque transfer from the engine to the drive. Okay, so it, as I said, it works in 7 different modes. One is purely electrical traction mode. So this pure electrical traction mode represents the engine is turned off and the vehicle is propelled by only from the batteries. Okay, so pure electric traction, we are saying traction is nothing but it's we are saying it is the mechanism to drive your vehicle. Okay, so the motor which is driving your wheels is represented as the traction motor. So this is motor controller, and this is the battery, and this is your electronic coupler, which will couple the energy from the engine as well as energy from the battery, and that will be connected to your traction motor to drive this. So when we say only electrical, only battery will operate. So these battery pack will operate your motor, and based on that motor drive, your vehicle will be driven. Okay. So second is pure engine traction mode. So in this case, batteries are not operating, or batteries are idle. We are not using the energy from this battery pack. We are using energy from only from the engine. and that is sufficient to drive your vehicle. Hybrid traction mode, as I said, whenever you are driving in the hilly areas, okay, so in that case we require more power, and that more power can be obtained from engine as well as from the batteries. Okay, so that is hybrid traction mode. So we are obtaining from this engine as well as battery combined, and that combined power will be transferred to the motor. Engine traction with battery charging. So here this is, as we have discussed, it is similar to braking. Okay, in cruise mode or braking mode. So your engine traction, the excess power of the engine are used for charging the battery, okay, which is represented by this dotted line. Okay, engine power is used to charge your battery. Next is regenerative braking. In this case, the engine generator is turned off. Okay, so and whatever is the kinetic energy, the losses that we are getting because of braking of the system, so those losses are used to charge your battery packs. Okay, those will be diverted to charge the battery pack. Okay, battery charging mode, the traction motor receives no power and the engine generator is operated only to charge the batteries. Okay, engine traction with battery charging. So the difference between this 4 and 6 is here the traction motor receives no power, whereas the engine generator, the complete engine power will be used to charge the batteries. Here the excess power of engine we are using to charge the batteries. Okay, and hybrid battery charging mode. So in this case, both engine power as well as your motor power, traction motor power will be used to drive the to charge the batteries. Okay, so these are the 7 different modes in which your any hybrid electric drive works. It may be series, it may be parallel. It works in these 7 modes of operation. Okay, any doubt in this? Series, why we are calling that as series? The coupler, which is coupling your input power to the transmission, is done through the electric motor, which is connected in series with the IC engine or in series with this IC engine generator. Okay, and that is why it is known as series. The advantage of this IC engine operates almost stationary, or the optimum use of IC engine power will be done. Okay, so that is the main advantage of this basically hybrid engines. And because there is no mechanical connection between your drives, it will be driven by electric motor, and internal combustion engine can be installed in the different location. So your drive system is connected through the electrical system. There is no mechanical coupling exists. There are no transmission, no gearbox existing. Your drive, your wheels are driven using the electric motor in case of this hybrid. Okay, and hence mechanical coupling is exist, and hence we can just mount your IC engines and drive electric motor at different locations. What are the drawback of this? Basically, the main drawback is because the traction motor is the only power plant propelling the vehicle, that is driving your vehicle. The complete vehicle driving, the wheel drive is controlled through the motor, which is directly connected to the differential. Okay, it must be sized to produce enough power for optimum vehicle performance, and that is the main drawback of this. Apart from that, the multiple energy conversions are taking place here. For example, your engine energy is converted into electric, which is given to the generator, and again that electric energy is converted into mechanical which is given to the traction motor to drive, to rotate the traction motor. Okay, so if the normal mean losses of individual component is considered, the total loss we are getting as 30%. Okay, and the inefficiencies of generator and traction motor may cause significant losses. Okay, so these are the drawbacks, and that can overcome in the parallel hybrid architecture. Okay, so in this particular architecture, we are connecting separately your IC engines, and this power converter assembly is connected to the transmission through the mechanical coupler. Okay, so this mechanical coupler is nothing but, again, you can think of it is a gearbox that we are using to couple or to just connect these two powers to the transmission. Whereas initially, so this one is getting directly connected to drive your wheels. Now we are using that mechanical coupler, which is nothing but a set of clutch and gearbox. Okay, so in this case, as we have discussed, it will work in all those 7 modes: individual power supply from the IC engine, the individual power supply from the electric motor. Okay, combiningly we can give power to the transmission. Okay, the power from IC engine, electric motor can be used. So excess power can be used to just recharge the batteries. Here you can just clearly observe. Okay, so excess power can be used to charge the batteries. The traction motor or the losses which we are having at the time of braking, so those losses or that power can be used to charge the batteries. Okay, so that means it will work in the similar way, but only the difference, as we are putting here mechanical coupler. Okay, so it is giving us more better efficiency as compared to the series one. So the advantages of parallel hybrid over the series is both the engine and electric motor directly supplies torque to the driven wheels, and no energy conversions are occurring here. Okay, so it is compact because there is no need of additional generator. One more thing, that so this particular part is existing generator, and because of what the energy conversions are taking place, so this generator part is not existing. Okay, so engine is directly coupled to this mechanical coupler. Okay, so that is doing the job of your torque multiplication or whatever speed increase. Okay, and here your motor is also directly connected, and because of that the size has been reduced, it has become compact. Okay, the main disadvantages, we are using the mechanical coupling between engine and drivetrain. Okay, the drive wheels. Since then the engine operating points cannot be fixed in a narrow speed and torque, and because of this the operating points will be limited. Okay, so another drawback is the complex structure, obviously. Okay, so this is the difference between series and parallel architectures. Okay, drawbacks and all those working we have discussed. So just to combine the advantages of both series and parallel, so this is what is known as the hybrid architecture, where engine is coupled through the mechanical coupler to this transmission, and it is also behaving like the parallel one. Okay, so separately your engine as well as motor is driving your transmission, whereas mechanical coupler is used only to connect your IC engines. Okay, and hence it is known as hybrid architecture. Okay, working operating modes are same as what we have discussed, and this is somewhat the complex and modified structure. Okay, where your IC engine is directly coupled to this transmission as well as it is coupled to the batteries. Okay, here we are not using or through this generator, the power coupler is used to charge batteries or to transfer that to the electric mode. Here two separate power charges we are using. Two separate power charges we are using for charging your batteries, as well as it is to pass in the IC engine power to the transmission. Okay. That means here separately it will be coupled to the transmission, and the excess power through this power converter it will be used to charge the batteries. Okay. Whereas this power converter will be used to couple your to drive your motor vehicles whenever we need to supply the additional energy to the transmission. Okay. And whenever we don't require this power, electric power motor that is again acting as a generator will be again connected back to this battery to charge that particular battery. Okay. So these are the four most commonly used architectures, or what we can say is the changes in the architecture starting from series to the complex hybrid structure that we are getting in case of this D, the last figure. So this is all about your hybrid drive classifications or hybrid drive types. Okay. So apart from that, it can also be represented as micro hybrid, mild hybrid, or strong hybrid. Okay. So it depends on what are the controls or the capabilities your vehicle is having. If vehicle only has the start and stop power, okay, engine shutdown whenever you are waiting at the signal, or whenever you have halted your vehicle. Okay, so in that particular case, it will only control your engine. It will automatically shut off and just on the engine. Okay, so that comes under micro hybrid. It is also part of hybrid because it is utilizing the engine power. It is saving your engine power. Okay, by automatically controlling the engine on off power. Okay, so another one is it is mild. Okay, recuperative, that is nothing but regenerative braking. Okay, and additional motor supply, that comes under your mild. And strong hybrid vehicle is where your all electric vehicle driving comes under your strong hybrid vehicle. Okay, so this is all about your hybrid vehicle classification. Any doubt you're having in this? Yes, students, any doubt?
No, ma'am.
So this ends your hybrid. Now we have left with only 5 minutes, and I think we will continue this electric vehicle block diagram or drive system discussion. And tomorrow I'll start with your second unit also. Okay. So today I'll upload all these PPTs on this team. I think you might have observed I have created one more team because my existing team doesn't allow me all the controls of classroom, okay, like assignment creation and all those things. And that is why I created another team, and I have added almost everyone. If anybody has left, please let me know. Okay. So and you are supposed to upload, I have created one assignment known as your experiment number 1, where you are supposed to upload your screenshot of the circuit that you have implemented for wiper control, and the post lab questions. I wanted to tell you, you have to write it by hand, otherwise it will be simply forwarded those things. Okay, it will be simply copy and paste it. So I want everybody has to write the post lab questions by hand and then upload the photocopies of that. Okay, so for each assignment, each lab assignment carries 10 marks, and finally out of that you will be evaluated. You will get marks for the 30 marks that is allotted for journal. Okay, so everything now I'll just create their folders or assignments or quiz, whatever, and you are supposed to use that class or that team for uploading your documents. Okay, so for today I think we'll stop here. If you are having any doubt, we have almost completed our first unit. Okay, tomorrow I think it will take 5 to 10 minutes, but for today I'll stop here. Okay, electric vehicles we'll discuss tomorrow, and I'll start with the second unit. And in second unit I'm starting with sensors first, and sensors, actuators, and then we'll discuss the remaining part of those. Okay, then we'll see. Any doubt? If you're having any difficulty, are you facing in implementing the first experiment?
No, ma'am.
Okay, I think very few, 4 to 5 students have tried. Others might have tried, but I don't know. Okay, so you have to finish. The deadline is till this Friday. So every Friday we will complete one practical, and next Friday will be the due date to submit the required documents. Who is moving this cursor? Okay, we'll stop. I'll end the meeting and we'll meet tomorrow. Okay, at the same time. I'll end the meeting. Okay.
Thank you, ma'am.
Okay.
Thank you, ma'am.
Thank you, ma'am.